3.4, 3.5, Part 2, Building Polynomial Functions from Roots. Number 1, the fundamental theorem of algebra states that each polynomial equation has the same number of complex roots as the degree of the function. So remember, if we have a complex root, a plus bi, we include both real and imaginary roots. So for example, in this polynomial, 3x squared plus 4x cubed minus 5x plus 6 equals 0 has 3 roots. And remember, this is the degree, the one with the largest exponent. Okay, and number 2, the complex conjugate theorem states that imaginary roots come in pairs, which means conjugates. So we have a plus bi and we have a minus bi. So, for example, if I have 3 plus 2i is a root, so is 3 minus 2i, because they come in pairs. So what factors of polynomials are associated with these two roots? Well, we have the factor x minus. We always start with that. So we have x minus the quantity 3 plus 2i, and if we expand that, we get x minus 3 minus 2i as one polynomial. And then we need the other one, x minus 3 minus 2i, which after expanding, we get x minus 3 plus 2i. It's also important to know that irrational roots also come in pairs. So an irrational root is a number that can't be represented as a fraction. So if we have a plus root b, we also have a minus root b. So for example, if we have 1 plus root 5, then so is 1 minus root 5. And again, the factors associated with these are x minus 1 plus root 5, which equals x minus 1 minus root 5, and then we have x minus 1 minus root 5. And we have x minus 1 plus root 5. So now think about how we've been finding zeros of polynomials. So if we have x squared plus 2x minus 15, we've been factoring it. And we get x plus 5 and x minus 3. And then when we find the zeros, we apply the zero product property, and we have x equal to negative 5 and x equal to positive 3. So now we're going to work the problem in the reverse order. So if we expanded it, or if we started with the zeros, x equals negative 5 and 3, then we could write the factors by using the zero product principle. So we'd have x plus 5 and x minus 3, and then we would expand it. We would FOIL this out, and we'd get x squared plus 2x minus 15. Now, this example was simple. So we need a strategy for more complex problems. So the first one is you need to consider given roots, determine any implied roots, conjugates, or irrational pairs. You need to generate all the factors for those zeros, incorporate multiplicity that's greater than 1, check that number of factors in the multiplicity of each are consistent with that degree of the polynomial, and then we always need to expand the polynomial to standard form. So let's look at an example. Find a cubic function that has zeros at negative 3 and 2, but 2 has a multiplicity of 2. So we have f of x, and if I have a 0 at negative 3, that means the factor is x plus 3. And if I have a 0 at 2, that means I have a factor of x minus 2, but this one has a multiplicity of 2. So now we need to expand. And if you notice and you look at the graph to the right, at positive 2, we show that multiplicity of 2 by hitting the x-axis and bouncing up. And then at negative 3, we go straight through. So the first thing I'm going to do is expand the x minus 2 squared, and I get x squared minus 4x plus 4. And now I'm going to distribute with the binomial and trinomial. And I get x to the third minus 4x squared plus 4x plus 3x squared minus 12x plus 12. And when I simplify and add like terms, I get x to the third minus x squared. This 4 should be 4x. So we get x to the third minus x squared minus 8x and then plus 12. And again, we always need to give our final answer in standard form. Okay, so now we need to find a quadratic function, which implies that we have a degree of 2 where we know that 1, 0 is 2 plus I. And since we know complex conjugates exist, then the implied 0 is going to be 2 minus I. So now we need to write these as factors. So let's call this polynomial G. We have the factor x minus 2 plus I and x minus 2 minus I. So I'm going to simplify each factor first, and then we're going to start multiplying. So on the left, we have x minus 2 minus I times x minus 2 plus I. So now we're going to distribute. And when we do that, we get x squared minus 2x and plus xi. Now we need to move on to the second term in that left polynomial or factor. So we have negative 2x plus 4 minus 2i. And then our final one is going to be minus xi plus 2i and minus I squared. So now we need to go through, I'm going to color code this. Now we need to go through and we need to cross off anything that we don't need or that cancels out. So we're going to cross off positive xi and negative xi, negative 2i and positive 2i. Now it's also important to note that I squared equals negative 1. So technically this is like saying minus negative 1. Okay, so let's simplify. We have x squared minus 4x plus 4, and then we have minus negative 1, which turns into plus 1. So our very final answer is x squared minus 4x plus 5. And if you look at the graph, we don't see any actual x-intercepts, and that's because both factors, our only two, were complex numbers, so we're not going to visibly see them on our graph. Okay, so now we're going to find a quartic function, which implies we have a degree of 4 with zeros 2i and negative 3. So the only implied 0 we have here is that we have positive 2i. So since it's a quartic, this means that negative 3 must have a multiplicity that's equal to 2, because it's the only way we can get 4 zeros. And if you look at the graph, it has a multiplicity behavior of hitting the x-axis and bouncing back up, which implies an even multiplicity. So let's write it in factored form. Let's call this polynomial h. So we have h equals x plus 2i, x minus 2i, and then x plus 3, but it has a multiplicity of 2, so we square it. So I'm going to FOIL out the two left factors, and then I'm going to expand x plus 3 squared, all in one step. So I'm going to get x squared minus 2ix plus 2ix minus 4i squared. And then x plus 3 expanded, which is x plus 3 times x plus 3, and you need to FOIL it. You get x squared minus 6x plus 9. Not minus, sorry, plus 6x. Okay, I'm going to simplify, and I know right away my two middle terms cancel out, and I squared is negative 1, so technically this turns into plus. It turns into plus 4. So we have x squared plus 4 times x squared plus 6x plus 9. And now we're going to expand this. So we have x to the 4th plus 6x to the 3rd plus 9x squared plus 4x squared plus 24x plus 36. And again, we combine like terms, and we get x to the 4th plus 6x to the 3rd plus 13x squared plus 24x and then plus 36. And this is our final standard form answer. Okay, so now we're going to find a quartic function, which implies, again, that we have a degree of 4 with zeros 1 minus root 2 and 1. So we don't have an imaginary number here, we have an irrational number. So our implied with the irrational root theorem means that we also have 1 plus root 2. Now, since it's a quartic function, this means 1 has to have a multiplicity of 2 for us to have 4 zeros. So, factored form, h of x equals x minus 1 minus root 2, x minus 1 plus root 2, and then we have x minus 1 quantity squared. So that will give me x minus 1 plus root 2, x minus 1 minus root 2. And then over here, I'm going to have x squared minus 2x plus 1. So I'm going to FOIL the left two factors first. And I'm going to get x squared minus x root 2 minus x plus 1 plus root 2. And then I have plus x root 2 minus root 2 and minus, now root 2 times root 2 is like saying the square root of 2 squared, which is 2 squared is 4, square root of that is 2. So that undoes itself, so you get minus 4. I'm sorry, I just contradicted myself, minus 2. And then this guy's going to tag along, but I'm run out of room. Well, maybe I can squeeze it in. X squared minus 2x plus 1. Okay, so I'm going to simplify first and cancel things out. I can cancel out a x times root 2 and a positive x times root 2. I can cancel out a root 2 and a minus root 2. And that's it. So we're left with x squared minus 2x forgot to cross this one out, minus 2. Nope. Sorry, I forgot about that 1. So I have minus 1. All right, and then I just carry down x squared minus 2x plus 1. So we're going to distribute again. I usually start with the first term and multiply it. First term on the left, multiply it by all 3 terms on the right, then move to the middle term on the left, times all 3 terms on the right, and then your last term on the left times all 3 terms on the right. So that gives me x to the 4th minus 2x squared cubed plus x squared minus 2x cubed plus 4x squared minus 2x. Then we have minus x squared plus 2x and then minus 1. And when we simplify, we get x to the 4th minus 4x to the 3rd plus 4x squared. And then my negative 2x and positive 2x cancel each other out, and then we just have minus 1. So my final answer in standard form. Okay, our last example. A cubic, which implies we have a degree of 3. We have a complex conjugate, so this means we have an implied 0, which is 2 minus I root 3. So we have 3 there, so there's no multiplicity. Okay, let's write it in factored form. We'll call this function j. So we have x minus 2 plus I root 3, and then x minus 2 minus I root 3 times x plus 1. Next step gives me x minus 2 minus I root 3 times x minus 2 plus I root 3, and then x plus 1 tags along. So if I were to FOIL this all out, or not FOIL, but distribute this all out, I would have x squared minus 2x plus ix root 3 minus 2x plus 4 minus 2I root 3 minus ix root 3 plus 2I root 3, and then I would have minus I squared times 3, or you could say 3I squared. And then all of that is times x plus 1. All right, so we'll simplify this first, and then we'll multiply it by x plus 1. So when I cancel things out, I cancel out ix root 3 and negative ix root 3, negative 2I root 3 and 2I root 3. So this gives me x squared minus 4x plus 4, and then it's going to be plus 3 times x plus 1. And real quickly, I'm just going to add the 4 and 3 and get my 7. And now we're going to distribute this trinomial and this binomial, which will give me x to the third minus 4x squared plus 7x plus x squared minus 4x plus 7. And when we combine everything and all our like terms, we get the cubic function x to the third minus 3x squared plus 3x plus 7. Again, in standard form.